We have a compound. This compound contains hydrogen, carbon, and chlorine. And we have percentage of every atom. And we have an extra information, which is the molar mass of the whole compound. Now we can follow the strategies that I mentioned in the previous short. In the first step, we will assume we have 100 grams of the sample, which means according to the percentage that we have, chlorine is 71.65 grams, carbon is 24.27 grams, while hydrogen is 4.07 grams. If we divide these masses over their molar masses, we will get the number of moles of each of these atoms, which we need to determine the empirical formula. For the chlorine, moles, for example, equals the mass divided by the molar mass of chlorine, which is known from the periodic table. For the number of moles of carbon, we will use this mass and divide by the molar mass of carbon from the periodic table. And for the H, we'll make the same to get the empirical formula. We will divide all of these moles by the smallest. So we'll divide each number by this number to get how many moles of each atom in this compound. And this will give us the empirical formula. We have to round to the nearest integer number. So it means that chlorine has 1 mole of carbon, and 2 moles of. To determine the molecular formula, we should multiply the number of moles of each atom by an integer number. We need 2 pieces of information. The first one is the mass of the empirical formula, and we can calculate it by adding all the molar masses of each atom in the empirical formula, and then the molar mass of the whole compound, which is given in the problem. We have the molar mass of the whole compound in the problem. We will divide it by the empirical mass that we calculated from step 4, and we will get 2, which means we will multiply the number of moles here by 2. As a result, we will have 2 carbons, 4 hydrogen, and 2 chlorines.